So we are now going to look at the Earth. The Earth is a magnet. Research has shown that the Earth is a magnet. Can you believe that? We are staying in a magnet. Now the question is, if you look at this question, why is the Earth a magnet? Is there evidence, scientific evidence, that shows that the Earth is a magnet? Yes. Number one, the Earth has poles. North Pole and South Pole. Just like any other magnet, the Earth also has poles, the North Pole and the South. So we have the North Pole of the Earth and the South Pole of the Earth. Secondly, the Earth also attracts things. When you throw a stone up, you realize that that stone comes down. Why does it come down? Because the Earth is attracting that stone. So the Earth attracts things, and if it attracts things, you see, the Earth attracts things, and therefore it has a magnetic field. Every magnet must have a magnetic field. So the Earth also has a magnetic field because it attracts things. Now, how does the magnetic field of the Earth look like? Now that one takes us to the next question. Sketch the magnetic field of the Earth and briefly explain. So you don't just sketch, but you go ahead and explain. How does the magnetic field of the Earth look like? Now, experimentally, the magnetic field of the Earth is actually in form of straight lines, and those lines must be parallel. So the magnetic field of the Earth are straight parallel lines. So when I tell you sketch the magnetic field of the Earth without explaining, you just simply draw parallel lines, vertical, not horizontal, vertical parallel lines, and then you put the arrows. And the arrow, according to geography, this is the north of the Earth, and this is the south of the Earth. Now when you look at these arrows, they appear to be coming from down going up. They are coming from south, they are going towards the north. So the magnetic field of the Earth, let's look at here, that the magnetic field of the Earth are straight parallel lines, you see, and those lines are drawn in such a way that they are from the south to the north. You see, they move from the south and they go towards the north. Geographically, according to geography, this is the south, this is the north. So the magnetic field of the Earth moves from south going towards north. Now that one happens when there is no other magnetic influence. What does that mean? The magnetic field lines of the Earth, they are straight parallel lines. They move from south, they go towards the north of the Earth according to geography, and that one happens if there is no other, you see this word, if there is no other magnetic influence. What does that mean? If there is no other magnet near the Earth, then these lines will remain straight. But if there is another magnet, they will not remain straight. So let us see, when you bring another magnet near the Earth, such that you have two magnets, the magnet you have brought and then the Earth also, what will happen? Automatically the magnetic field of one will affect the other. Now let's look at that. Sketch the magnetic field pattern for a bar magnet with its north pole pointing geographical north. You see? So if you have a bar magnet, which is actually here, north and south, north and south, north and south. So this is a bar magnet. And then remember, this is the north of the Earth, and this is the north of the bar magnet. So you are making the north of the Earth and the north of the bar magnet to be in the same direction, or the south of the Earth and the south of a bar magnet. So what happens? This magnet here has a magnetic field, and the magnetic field moves from north. You see this? You see this arrow? It moves from north to south. It moves from north to south. You see? But the magnetic field of the Earth also is there. The straight parallel lines, these ones. The magnetic field of the Earth. So we have the one of the bar magnet moving from north to south, then we have the ones of the earth. Now, the magnetic fields for the bar magnet and the earth, one will affect the other. And I want you to see this. This magnetic field of the earth, you see, earth's field, they are supposed to be straight parallel lines, you see, straight parallel lines. Those ones which are very far will remain straight, but those ones which are moving, they are near the magnet, they will not remain straight. So what will happen? They will bend, you see. They come when they are straight, but they end up bending. They come when they are straight, they end up bending. Even here, those which are near the magnet, they will be affected, you see. So even these ones of the magnet, the bar magnet, when they try to come, because they are close to what? The one of the field, they will also bend like this, you see. They will bend like this, they will bend like this, but the arrows will remain the same. From here, going where? Up. So, if somebody asks you that sketch the magnetic field pattern for a bar magnet with its north pole pointing geographical south, and you did this, this will be very, very correct. So you get your marks for direction, for the pattern, and so on. I remember talking about this. Now, when you change the magnet, you see, you bring the south this side and bring the north this way. By the way, the magnetic field, the direction, the north and the south, the compass direction of the earth does not change. North remains here and the south is this one. But you can change the one of a magnet. You bring the north this way, south this way. That was the first case. Now our second case, we have taken the south. So the south pole of the magnet is facing the north of the earth. And the north of the magnet is facing the south of the earth. What will happen? Still, let us see this. The magnetic field of the bar magnet alone moves from north to south. Moves from north to south, as you see the arrow. Now, when the field lines, the magnetic field lines of the earth come, they bend away like this. These ones also come, they bend away like this. So they create two neutral points. You see, this X is what? Neutral point. So we have X here, we have X here. Now, these are the magnetic field lines of the earth being affected, those that are near the magnet. But we have not drawn those ones which are very far. But if we were to draw, they would remain straight lines. Because they are very far from the magnet, they would remain straight. But these ones which are near, they will be affected like that. So this is very correct. If you bring a bar magnet such that the south pole is facing north and the north pole is facing what? South. Okay. Now, these areas we have called them neutral point. What is a neutral point? Some time back we talked about a neutral point. Today we are putting it in the form of a question. If somebody asks you what is a neutral point, remember in this area the magnetic field lines don't pass. So the magnetic flux does not pass here. So the flux density is 0. So we define a neutral point as it is a point, as the word says, neutral point. So it is a point where or at which the resultant magnetic flux density is 0. Where the magnetic flux density is 0. Now, we also have other definitions which we are yet to look at. Let us have a short commercial break, then we come to that.